Now we will discuss on the chapter 9, the GIS data acquisition. So basically, when we talk about the GIS data acquisitions, example here are the data or the map of the different kind of maps, which is the fish sampling, fishing density, boat types, currents, bathymetry, set scan, transect, and habitats. All of these informations are being captured or acquired through different kind of thematics and themes, different kind of approaches, being combined together to give you an idea of how does the activities or the phenomena happens within the shorelines. That's the idea. So when we talk about the data captured, there are two types of data captured basically, which is primary data sources, where those data are collected in the digital format, which is you go to the ground, you collect your data, you get the points, you key into the system, in the GIS software, and these are the primary sources. While the secondary data sources are digital or analog data sets that were originally captured for another purpose and need to convert into a suitable digital data, such as hard copy maps, reports from the statistical departments or from the health departments, and many more. And in the spatial data component, we do have the remote sensing system to collect the data. You use the photogrammetry, drones, and more, or you use a normal survey using the GPS to pinpoint the location. And for the attribute data component, using the remote sensing, the remote sensing analysis, you go for the fieldwork to do to collect the data, do the interviews, or based on the reports available by the authority. So what the nature of the spatial data? So spatial component, they must have the relative positions between objects, the coordinates. Okay, the attribute components, they must have the spatial object characteristics, the relationship between objects, and also there will be some temporal elements. So in the spatial data criteria, you must have a XY coordinate system, the shape of the features, could be the area of size or perimeter, the distance between one point to another, and the neighboring features. So when we talk about the data captured or data collections, or data automation, or data conversion, data transfer, or data translation and digitizing, it is a time-consuming, a tedious and expensive project. Mostly for this capturing only, it consists about 15 to 50% of the total cost of the GIS. Okay, so if it include the cost of the human being, it can goes up to 60 to 85% of the cost. And data basically, it comes into two format, which is analog and digital data. So especially when we do a study which consists data from the previous years, let's say from 1950s. During that time there's no computer and we only have a map, printed map. So analog data is a physical products that we have to digitalize later, while digital data is information in the computer form, such as the satellite data and more. Okay, so this is an example of the cadastral map, which is in the digital form. Okay, from this you can capture, but of course if you want to look into the different changes and data and so on, therefore we have to digitize the old data and put it here. Let's say you want to see the changes of the ownership during post 1950s until now. So what you can do is you have to collect all the data from the analog, convert into digital, and overlay with the new data, and you can see the changes of the data. Okay, and there are various sources of the way we can get the different type of data. Example, maps, aerial photo, satellite images, and tables data, and many more. And the good thing is GIS is able to capture these different types of data from the various sources. Okay, However, to create a database such as capturing data is the initial stage and time-consuming task of any GIS project. Surprisingly, the analysis is a very simple part. Although, it seems complicated, but in order to prepare the data to be able to be analyzed is very time-consuming. That's why in data collections we must have a workflow to ensure that the data that we collect are data which has a quality and able to be analyzed. So the first step will be a planning, which includes the establishing the user requirement, gather the resources, and develop the project plan, and then we go for the preparation on how to obtain the data. If the data is a poor quality, how to redraft it, how to edit the scan maps, to remove noise, and to setting up the GIS hardware, because we have to know that GIS data requires a lot of storage. Therefore, we must have a good or big storage to be able to collect all of those informations. Digitizing and transfer data, where a lot of efforts have to be used, work hour, man hour, time, and many more. And after that, they must have some editing and improvement of the data, to design, to validate data, to correct the errors, so that the data is ready to be analyzed. And last will be to evaluate the project, either we achieve the target or it becomes a white elephant. So many kinds of the data collections can be used, such as LiDAR, photogrammetry, aerial photo, digitize, map scanning, set data, fieldwork, survey, data entry, and existing digital data. So some of it we can use LiDAR, where it is very good to derive the measures to train elevations until 1 centimeters sensitivity. Is highly accurate, is capable to operate over rugged terrain, and it is quite fast to operate it, and it shows in the 3D. Okay, now we can use drones to go to do the LiDAR system, right? And the photogrammetry also is another quite cheap data collections used to process the photogrammetry. Okay, so this is the primary source which is used to process of the photogrammetry completions of the aerial photography. Okay, usually we use a stereo plotter of the aerial photos, have X and Y, two images which are different angle, overlap each other, and blah blah blah. Yeah, and those photos will be auto corrected, create auto photo, and from this photogrammetry we can extract the DM. However, the accuracy will be lesser than the LiDAR. Okay, and we can use drone to produce it. And the third one is the digitizing, where basically we using human being, a person, to what we call to trace, to scan the map and trace all the shapes of the map and turn into the digital data. So it's a very tedious thing, time consuming, and you have to have a lot of effort. And of course, map scanning as well is one of it. Okay, using the microscope, using the big scanner. And satellite data is a part of the main data sources for the GIS. Okay, and of course the field data collections, such as using the GPS to taking the data, or using the conventional survey techniques to collect the data, right? Okay, now is the survey. We're using the theodolite, using the total stations. So the surveyors, we can collect the data from using this through the surveyors, and the surveyors might provide you with the most accurate or the highest accurate data accuracy data available, and after that you can include the data properties. And of course there are some tabular data entry. All of the vector data you need to key in the data in the table, which is a which is a GIS database. So it is a manual data. It is a manual effort. There's no quick process to do it, and it's also time consuming. Okay, and there's a lot of the translation of existing digital data and blah 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 and many more. So that's all for the data acquisition. Thank you very much.